Chapter 9 goes into more detail about earthquakes and volcanoes. So we're going to start with volcanoes. And I'll put, there's several links on your study guide that have some just really nice images of volcanoes. And just a lot of destruction and death and property damage as a result of volcanoes, earthquakes, and the ground shaking, loss of life through tsunamis. So we'll look at all of those events related to that. When we think about volcanic eruptions, you want to be able to identify two major types: explosive lava versus effusive lava. Effusive lava is common in divergent earthquakes. Typically, the flow of the magma into lava is very calm. It's not dramatic. The magma is not very sticky. It's very, very hot, kind of like Hershey syrup as opposed to hot fudge. And this is responsible for the creation of largest mountains on Earth, shield volcanoes, and of plateau basalts. The other type of lava is explosive lava, and this is much more common in pyroclastic flows, in stratovolcanoes, and typical as a result of subduction zones. A lot of pressure built up. The silica is very sticky and very thick. When the lava is expressed on the surface, there are two types that are important to know the difference between A'a lava and Pahoehoe lava. You can see that Pahoehoe is very ropey and smooth, and the A'a is very sharp and angular. These are terms that come from lava in Hawaii. A small type of volcanic landform is a cinder cone. This is created. They're the smallest volcanoes. They have a very well-defined crater. They're usually less than about 1,500 feet high. They're from explosive volcanic activity, and they're made up of cinders or small pieces, not large rock or flows, but just kind of exploded gravels and cinders of volcanic lava. Stratovolcanoes or composite volcanoes are so called because you see the different stratigraphy or different layers as you have different flow events. So they are very explosive. They develop this cone shape. Those two have a crater, but you might have one explosion of flowing lava and the next explosion of cinders, another explosion or eruption of ash, and this creates these different layers. And very common, Mount Fuji, Mount St. Helens are examples, Mount Etna are examples of composite volcanoes. So make sure you understand those differences. The other volcanic landform are shield volcanoes. Now these come from effusive eruptions, and as I said, they're very hot lava, very runny lava, and instead of building thick-sided, they create very gentle sloped events. And this is Mauna Loa, and it is one of the largest landforms on Earth. If you go from seafloor up to the chain of Hawaiian Islands, where it's above the ocean floor. So the other landform created with effusive volcanoes are flood basalts, and we'll look at those in just a minute. Calderas are composite volcanoes that have undergone a massive explosion. So this is an aerial photo of Crater Lake. Yellowstone Lake is a caldera. There's a fun movie out called, I don't know, it's a monster volcano eruption, and it shows Yellowstone is getting ready to blow again. But these create large basins, and what happens is you have a stratovolcano on the landscape, and they get superheated, and with a very huge, very large eruption actually blows all of the supporting material that is under that mountain, and as it empties itself, it creates a kind of an empty space and collapses in on itself, leaving the crater. Another picture of Crater Lake. Bathyllus we looked at earlier, looking at under the rock cycle, looking at Yosemite, and this is a sill. This was a volcanic conduit that flowed out from, you can see this throat of this old volcano and these arms or these radial pipes flowing out. Basalt flows. The picture on the left shows layer upon layer upon layer of what are called flood basalts. These are effusive volcanic deposits, and they flow for miles and miles, and over time create very thick, very dense landscapes. A lahar is a mud flow or debris flow from a volcanic eruption that is superheated mud. And this is what happened in the Nevado de Ruiz volcano. And this superheated, very fast-moving flow of mud and hot ash flowed down the volcanic sides. Melted ice consolidated with mud and ash, and very dangerous, very dramatic events. You could also have pyroclastic events, which are just basically explosions of ash and volcanic bombs. So here's a stratigraphy showing some layers of ash where this large rock has kind of blown out of the volcano and landed on an ash bed and then covered with more ash. An ash flow, superheated ash flow. This is the event, an example of in Pompeii, where people were kind of lithified or solidified in place because they were covered with this hot molten ash that people breathed in and kind of encapsulated them. So I think the book has some incidents of volcanic eruptions and the deaths that have happened, and they make the point that we aren't seeing more deaths from volcanoes and earthquakes. We're just actually seeing more recording and more documenting of these deaths. But it's interesting to see that some of the deaths were not from the incident itself, but from, for instance, starvation, so covering up the land, so not able to grow food on the fields, or in Indonesia from tsunami, in Pele from ash flows. And I just love this. This is in Hawaii, and you can see people kind of fighting the movement of this lava flow toward the houses, trying to cool off the edge, trying to cool that lava, create a crust so maybe it will divert the path. This is curtain lava, and even though that this is very effusive and it's not very eruptive, it can be very dramatic. And using bulldozers to try to push the river of lava and divert its direction, and kind of the end result when we fight nature most of the time.